So good morning, I'm Jaclyn Ocumpaugh. I'm 1 year in at the University of Pennsylvania at the new Penn Center for Learning Analytics, where I've primarily done a lot of work with Ryan Baker, and we are sort of just now moving into languagey spaces because it fits my background as a sociolinguist and his as a data analytics person. And we have worked with a lot of people because that's sort of how our projects go, but especially with Stefan Slater, who unfortunately wasn't able to be here today, but is a star PhD student and deserves lots and lots of credit because we've really, really worked this poor kid the last couple of years on this project. I'm going to be talking about a project that's been ongoing for several years now with the Assessments ITS system, which is a math software that's designed for middle school mathematics, but it is actually something that's very adaptable. Teachers can put their own input in, and so we can see things occasionally that we wouldn't expect, like high school genetics or college level statistics or whatnot that's showing up in it. But it's used by, I think, over 100,000 students a year at this point, primarily in the Northeast, but certainly spreading. And it provides us with a really rich set of data because in addition to student actions and the timestamps and skills and whatnot that is available within that system, we've also been able to model sort of some short-term things that are of interest to learning. So sort of typical learning, like the moment when we think the kid has actually acquired the skill, but also whether they're on task or off task, depending on their behavior within the system. And we do that by sending somebody, in this case it was usually me, out into the field to watch the kids and then matching those observations up with the log files. In addition to catching behavior, we've also been able to do this with affect. So we typically code for boredom, confusion, engaged concentration, and frustration. We did not code for delight with this system because it tended not to appear super often. So things like that would either show up folded in under the engaged concentration if that was what was going on, or showing up as some sort of question mark code that we use for things that aren't like that. We also code for gaming the system. So this is things like the kid is guessing, say systematically from 1 to 43, what the right answer to a particular problem might be, which is the most extreme that we've seen. But certainly also things like abusing the hints, so not actually reading them and not waiting till he gets or she gets to the end of those hint sequences and going back and self-explaining. Certainly if they went through and said, okay, hint, 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 and read all of that, that's not something that we want to categorize as gaming the system. We've then been able to use these things to model longer term concerns, so we can not just predict who's going to pass the state exam based on the system, but also who's going to college and what their major is going to be. And we currently have a big data competition going on right now where we are inviting teams to predict who is going into a STEM degree program for graduate school or is entering a STEM career field. Right. So we have this really rich database, and we're able to predict things not just like learning, but the associated affective states, which turn out to be pretty important for modeling these longer term outcomes. And we want to know, what kinds of linguistic features with the problems might be associated with that. And so we've used a number of tools. We started off with W-matrix, which is a semantic tagger. We've used a lot of the cometrics features. The TALS features have been used, and of course, I've been abusing a graduate student for several years now, and he's had to adapt very quickly as we move along. He's pulled a few things that are pretty well established, but we also discovered we had a lot of things like HTML code that was showing up, which can be very predictive if teachers are using it in a common way, but for some things needs to be pulled, and then regular expressions within mathematics, we've been able to do sort of some basic modeling with that. Okay. We've had a number of studies out and a couple that are coming, and so we'll just kind of overview what we've been doing with that. The first big study that we had was a correlation study where we just looked at the W-matrix features, and we ran a post hoc analysis on that with the 6 outcome models that we had. That's a possible almost 3,000 correlations, and about a third of them were still significant after the correction. This allowed us to look at A few things. One of the things that was very nice for us to see, because you always have concerns when you're using models, is that we're getting some really strong confirmation for the affect models working. In the things that are predictive of things like confusion are also predictive of frustration in the same direction. And since those are two closely related outcomes, we like to see that. Things that decrease boredom seem to show up for higher engaged concentration and vice versa. This was also nice to see. We were a little concerned to see that higher gaming behaviors show up when higher learning is occurring, or at least they seem to be predicting, the linguistic features seem to be predicting the same direction on both of those. But we think that it's at least possible that we've got two different subpopulations, right? That we have some kids who are actually learning because those are the really important problems, and some kids who at that point are checking out. So it's not entirely surprising if maybe just a little bit disappointing. We're also seeing that differences in sort of academic versus colloquial text based on these features are showing up, and they seem to be driving a lot of confusion and frustration, which sounds terrible, except that we have seen in some of our research that when confusion and frustration are missing, so is learning. And so it's an interesting finding. It's a little bit surprising, and we are certainly keeping an eye on that. Right? We've also done this with TALS features. We used a smaller number of those more recently. We found that they were highly, highly predictive. So of the 800 some that we tested, 700 of them were statistically significant after corrections. And we found the same predicted patterns, so confusion and frustration features were very similar, boredom and engaged concentration features were very similar and in the direction that we would hope. We saw less overlap, this was sort of exciting, between gaming the system and learning than in the W matrix features. But we also saw that learning and boredom were showing up as being predicted by the same linguistic features. And again, our story on that so far is that probably there are some students who are very much engaged and some students who are on the verge of checking out. The other story on that is this is the moment-by-moment learning model, which means we predict that the kid learns on the problem before he or she gets it correct, which is maybe not an exciting experience, right? So again, this may actually just be a function of the way that we've operationalized learning in this particular moment. Okay. One of the more recent studies, because we have somewhere between 100 and 400 what math specialists would call knowledge components within assessments, and they are not always well labeled because of the crowdsourcing opportunities that assessments offers. So assessments does have a set of problems, a large set of problems that was developed by their own team, and it is fairly consistently labeled. But the stuff that gets inputted by individual teachers, sometimes from their textbook, sometimes from their past experiences, is usually not labeled very well. And when it is, it's not labeled consistently from one teacher to the next, or even across assignments with the same teacher. And so one of the things that we've tried to do recently is to do content modeling. And we've been able to identify 25 different contents, which is not exactly what we would hope, but definitely a good start. We've had some challenges with that because the numbers are considered distinct units when we go through this process. We've had to go through and do things through regular expressions and then recode those into semantic terms. And we've had to strip out a lot of things that were actually useful for other research programs. So the HTML codes that were actually pretty predictive in our earlier studies have to be removed in order for this to work. But we are able to use things like Unicode markers, and they actually are pretty useful. Right. So this gives us features that appear together. They don't seem to be just skills, but almost also sort of common phrases. So if we have a set of teachers who likes to warn kids that this problem is particularly tricky, that often sort of shows up in clusters with different things and turns out to be actually pretty useful. But we are able to discriminate between things like mixed and improper fractions and whole fractions. So we've got our work cut out for us, but definitely a good start. Like I said, we've had sort of extensive recoding required to deal with mathematical expressions and equations. And if you guys have a way around that, Stefan would like eagerly to hear from each and every one of you who has those ideas. But we're also continue to sort of develop in-house ways of dealing with this. Right. And then the last study that we've got out towards publication is headed to ACII. It's just been accepted. And we've done 6 regression models. So these are multi-feature models combining the W matrix features, the TALS features, the co-matrix features, the HTML features, and then a few things like whether or not the problem had hints available and that sort of thing. And we've done this for each of the learning outcome measures. We limited each model to 10 features so that we would have some interpretability. And so that we have things that can run in real time. We would really like to be able to run these things as needed in the classroom if we ever thought it was useful for intervention. And so the more concise that model is, the easier it is to do that. Of the findings that we've seen in there, academic words seem to reduce boredom. This confuses us too, although perhaps that's because the kids are learning and they like it, and that would be really awesome. And then we are starting to do some work with decision trees on these. And this is very, very preliminary, just coming out this week. But what we're seeing, for example, with boredom is that age of arrival and bigram type count are repeating and repeating and repeating, and we're getting more and more specific numbers. We're not entirely sure what that means exactly yet. We do see the only spot in the boredom analysis that's showing up seems to be due where we see a distinct difference between the different clusters in these. We have a 0.04 that you can probably barely see right here. The rest are in the 15 and 16 and 17 range. So that 0.04 is significantly lower by our standards within the system. Seems to be related to imageability. Right. So as frustrating as this is, boredom is our worst performing affect model. And so we're still going through the other systems, other outcome measures to see what other things are going through. It is one of the rarest affects that we code, thankfully, in the field. And so it's a little more difficult to develop just the basic model for that and then to adapt the linguistic features to then correlate with that. We sort of have to reduce our expectations. We expect the other models to be a little more revealing, but we are excited to see where this is going. Again, as I just said, the bigram type count, age of arrival, particularly for function words, and there seems to be some sort of magic or else really good noise that's happening between ages 4 and 5, that division keeps appearing over and over and over again in this model. And again, Stefan would certainly love to hear from you guys, as would I, if you have any thoughts about what that might be. Sort of the overall conclusions, we think we're coming across some fairly interesting findings, and it's particularly important to us to see the affect models used because they do seem to make long-term predictions possible for us. So we're looking to see linguistic features that don't just predict learning, but predict all the emotions and behaviors that are associated with good learning and good learning experiences. A few of these seem to contradict the stylistic barrier hypothesis, and we are, like I said, trying to figure out whether that is because we have subpopulations that are happening within the system that we need to take care of. Assessments, unfortunately, does not log consistently demographic information, and so we're sort of limited to what we can scrape together from what is available in the system. As far as we know, the field has not developed strong models for topics and for skills and for identifying things that are important to mathematics genres within language analyses. If we are missing something, please, please, please forgive us and let us know. We found some tricks that can help, certainly the data processing, which seems to vary considerably depending on which kind of analysis you're running. And correlational topic modeling is something that's giving us some good progress. Again, I'm going to thank Stefan and just say that we need to do a lot more work, but we are excited by those results. Thank you guys very much for listening, and I won't make you turn all of your questions over to the workhorse, but I definitely want to make sure that we give him credit while still teasing him as much as I can from long distance. So thank you guys. Hi.
Do you have any examples of the kind of text that you're processing? My question was, could you give some examples of the kind of text that you're processing? I'm gathering they're like assignments and teacher
Right.
rather than student work?
So these are the math problems within the system, which I think we showed you one that did not have a ton of text when we gave the systems example. So sometimes they're accompanied by a diagram and a lot of text. If it was just numerical problems, we stripped those from this analyses. So these are just the ones that have a minimum threshold for words, and I think our minimum threshold was 50 for this the bulk of this work. We may have let that dip down quite a bit for the semantic taggers because it seemed less important when we're sort of dealing with a bag of words. I've pulled some examples towards the end that I didn't use. And so if they're still there, one of the things that we saw is divided by means something very, very different outside of mathematics. Another challenge we had was we got very, very concerned when sex topics showed up as highly significant the first time we ran semantic taggers, because this middle school mathematics, and we were a little horrified. It turns out the American name Randy, when you use a British tagger, causes some issues. I appear not to have saved most of the example issues, and I apologize for that because I know how important that is. I do know, particularly for the model topics, the things like you have X number of questions or X number of hints left appears to be important. Stop and think kinds of metacognition instructions seem to be really, really important. And we don't know whether that's because the teachers have already identified problems that are particularly tricky, or because it is actually changing the way the student interacts with that particular skill. And it's definitely something that we would like to test. We do have some randomized control trials sort of in the chute, but we don't have good results from them back, in part because once you have this many features, it's sort of difficult to exactly figure out what the interactions are, and we're just getting to the more complicated models in the last 6 to 8 months.
Thank you so much. So many questions. I'm trying to decide which one to focus on. Thank you. So I think you said something like that there were differences in academic and colloquial texts, and that can drive frustration and confusion. And I was wondering if you could explain what you meant by that. And
so the TALS features include labels like academic text or academic words from a database that has been culled from previous research, and those seem to be correlated with confusion and frustration. But it appears they were actually driving them down, which was surprising. And we think, it also reduces boredom, which we also thought was a little unusual. But we think if you're getting new material and you're not having to sort through a ton of extraneous details, that's another feature that we've seen show up in the literature before, is that the sort of sexy word problems that people think might improve engagement, students get distracted by. And so it's possible that we're seeing some sort of interference we really need to run some RCTs to know for sure.